Our measurement is not always accurate and precise, so we need to look for the inaccuracies and imprecisions in our measurements. So these inaccuracies and imprecisions are given by the errors in measurements. So to look for it, we can estimate the errors in our measurements. So errors in measurements is the difference between a measured quantity and its true value. So it is the measure of how far away is your obtained measurement from the true or actual value of the measurement. There are three types of errors in measurement. So first is the blunder, second, systematic errors, and third is the random errors. Blunders are also known as personal errors or errors caused by carelessness and accident. So that's why it is also known as the accidental errors. Example of blunders are spilling a chemical before it can be measured. So if the chemicals are spilled and then you measure the volume of that chemical, that measurement cannot be used in the analysis of the data because that data will be affected by this outlier. So for example, madaming natapon, so syempre maapektuhan din nun yung ibang value sa dataset mo. So second example is a scale might read 21 cm. So for example, 21 cm yung talagang measurement, pero nasulat mo is 12 cm. So this is caused by the carelessness in your part. So by writing the wrong measurement in your observation notebook. So the measurements caused by blunders are disregarded when it comes to the analysis of the data set, kasi this will really affect this will greatly affect the measured or the result of your experiment. So the errors caused by blunders, so the measurement caused by blunders are disregarded when it comes to the analysis of the data. Second type of error is the systematic error, where it is defined as the errors due to identifiable causes. So these errors in principle can be fixed since the cause of this type of error can be traced. So pwede nating mahanap yung source of error, of systematic error. So errors of this type result in measured values that are constantly or consistently too high or consistently too low compared to the expected or true value. The sources of systematic errors are environmental, observational, instrumental, and theoretical. So these sources are already discussed in your module. So random errors, the third type of errors, are errors that are naturally occurring. These are errors due to unavoidable environmental conditions, and most of the time, the sources of this error cannot always be identified. So, random because the errors occurs randomly, so hindi natin malaman kung kailan siya nangyari, kasi random lang siya nangyari. So, for example, iba-ibang tao yung nag-measure ng isang quantity or ng isang property. For example, the length of a metal rod. So, madaming tao, for example, ang nag-measure. So, hindi mo alam. So, kung sino sa kanila yung nagkamali. So, hindi mo naman madaling madedetermine kung sino sa kanila yung nag-commit ng error. So, sources of error are environmental and observational. So, if the sources are identifiable, so it could be environmental or observational, and idagdag na din natin yung instrumental. So for observational error, so for example, there are many persons, many people who are involved in measuring the quantity or the value of the measurement, then one might estimate the value to, for example, 4, one might estimate the value to be 3 and other estimate it to be higher or lower than your estimation. So those are examples of observational error, and hindi naman nila yung sasabihin sa'yo, so they will just record it in the sheet, so in the recording sheet. So random lang siya nangyayari, so depende sa taong naka-assign doon sa pag-measure. Also in instrumental, because the precision of the precision of a measuring device are different from each other. So depende sa kung paano sila kinonstruct nung mga gumawa nung mga measuring device. So if you're going to represent random and systematic errors in graphs, so we will have the following graphs. So first, this one represents the both random and systematic errors. So if we have this line, so this line represents the true or the actual value, and this line represents our experimental value, the central value or the best fit line of this red line represents the best fit line of all of these data points, so the central value of all of these data points. So the central value of all these experimental values is consistently higher compared to our true value. So therefore, it represents systematic error since it is higher than our expected or true value. While it also represents random, because if you can see, the different data points, the different experimental values are scattered. So malayo sila sa isa't isa. On our second graph, it represents systematic error because although the values, the individual data points are closer to each other, however, their central value is the central value that represents all of these data points are higher than our true value. So that's why it represents systematic error. So in our third graph, so random error, we have here a graph that represents random error because again, so dito yung ano natin, yung best fit line natin, it lies along the expected value. So that's why hindi siya magre-represent ng systematic, but it represents random error because the data points are very much scattered. So yung iba mas mataas, yung iba mas mababa. So yun. And our last graph represents a data which has little random and little systematic error. So yan, so yung data points mo are closer to each other, and the central value that represents all the data lies along the expected value or closer. If it's not equal, then closer to the expected value. So this one represents precise and accurate measurements, graph number 4. Graph number 3 represents accurate measurements but not precise. Graph number 2 represents not accurate but precise measurements, and graph number 1 represents not precise and not accurate measurements. Okay, so in our next video, we are going to discuss how to estimate errors.